Good morning to one and all present here. Myself, Selva Prakash, working as a assistant professor in chemical engineering department at Erode Sengundar Engineering College, Erode. And today we are going to discuss about the topic the law of thermodynamics. In the thermodynamics, there are four laws. One is zeroth law, and another one is the first law of thermodynamics and second law of thermodynamics. Actually, in the last about this, it's on the process, so we can discuss about the further classes. Now we are going to talk about the session, the contents of these sessions. The first law of thermodynamics, the next one is second law of thermodynamics. In between this, the thermodynamics process and the first law, and the human metabolic and the first law, and the last one is heat engines and refrigerators and air conditioners and heat pumps. Okay, and the next another the continuity is entropy and second law of thermodynamics, order to disorder, and the another one is unavailability of energy and heat death, and the last one thermal pollution, global warming, and energy resources. The first law of thermodynamics, the change in internal energy of a closed system will be equal to the energy added to the system minus work done by the system on its surroundings. Okay, which means actually it is a theoretical version. Now we can also discuss with the mathematical expressions by using the del U equal to del Q minus del W. U is the heat energy and minus like is the energy transferring, so that we are using minus symbol in this slide, and the another one is work done. Okay, simply you all know about the del U is the internal energy, like the internal energy, how the internal energy is transferred into the work and heat energy. Okay, the last sentence is this is the law of conservation of energy written in the useful form of the system involving the heat transfer. Now in this diagram, the thermodynamic process thermodynamic process on the first law, an isothermal process is one where the temperature does not change, which means if there is an isothermal process, the temperature does not change. So what is meant by isothermal system? Which is when which process having the constant temperature is simply known as the isothermic process. Okay, now a refrigerator works isothermally. A set of changes takes place in a mechanism of refrigerator, but the system inside the refrigerator remains constant. Here the heat energy is removed and transmitted to the another surroundings. Another example process of the isothermal is the heat pump. Now we can also discuss about the what is the difference between the isothermal process and the adiabatic process. The word in the isothermal means constant temperature. We already know about the I said this just a few minutes ago, but Briefly means an isothermal process is a process occurring at a constant temperature. Okay, simply you have to remember this. An isothermal process is a process occurring at a constant temperature process. Okay, and now the next one is adiabatic process. Adiabatic process means that neither allows the heat transfer into the inside or outside the system. Okay, simply now you have the idea about the adiabatic system and the isothermal system. Adiabatic system means it's allows the heat transfer in and out, but the constant means that is the isothermal process. Okay, for example, a reaction takes place in the Denver flask. We all know about the flask. Okay, the flask system is the adiabatic system. Okay, now we already have an idea about the isothermal system and the adiabatic system. Now we have to use this as the application part. Application part means which is the example. Now I'm going to talk about the example of the isothermal system. The melting point of ice at 0 degrees Celsius is an perfect example of the isothermal system. The reaction in the heat pump is the example of the isothermal process. First one is melting the ice at 0 degrees Celsius, and second one is heat pump, and third one is the they all they all follows the bias rule in the thermodynamics process. After the session, I will tell about the bias law. Okay, now we have to simply know about the what is isothermal system. Okay, which the temperature its system remains constant is isothermal system. Actually, now we ready to able to say the mathematical expression. So that's why we have to tell about the del T equal to 0 means change in temperature is constant. This is the change in temperature remains 0 in the process. Okay, this is isothermal process. What is the in this isothermal topic we have to discuss about the power isothermal, which means isothermal power or power isothermal, the power which is theoretically required to compress the gas under constant temperature is the power which is theoretically required to compress a gas. Like in this diagram, this is the movable piston and this one is the ideal gas. Okay, now the power, what is the power applied by the moving piston is the power isothermal. Okay, now we already know about the constant pressure and constant volume terms. Okay, now why the constant pressure is greater than the constant volume? Actually, we all know about the pressure and volume terms in the school level also. But the molar heat capacity at the constant pressure is represented by the Cp. Heat capacity at the constant pressure is represented by the Cp at constant pressure. Okay, when a gas is generated, work is done to overcome the pressure, and there is an expansion in the volume with an increasing in the internal energy of the system. Repeatedly, the molar heat capacity at a constant pressure is represented by Cp at constant pressure. When a gas is heated, work is done to overcome pressure, and there is an expansion in the volume with an increase in the internal energy of the system. Therefore, it can be said that Cp is greater than the Cv. Okay. Now, an adiabatic process is okay. Before the we are going to adiabatic process, we have to conclude about the isothermal process. We already know about the isothermal process is the constant temperature process. Adiabatic process means that neither it allows the energy inside or outside the system. For example, flask is adiabatic adiabatic process. And then for some examples of the isothermal system is one is the melting ice at 0 degrees Celsius and another one is the heat pump, which mathematical isothermal system is being defined as the delta G equal to 0. The power isothermal is the power which is required theoretically required to compress the gas under the constant temperature is known as the power isothermal. Now it's time to briefly explain the adiabatic process. Okay, adiabatic process is defined as the process which no heat transfer takes place. Okay, no heat transfer takes place. This does not mean the temperature is constant. This does not simply note this point. An adiabatic process is defined as a process in which no heat transfer takes place. Okay, this does not mean that temperature is constant, but rather than no heat is transferred in or out from the system. Okay, we can simply know about the for an ideal gas, and if we consider an ideal gas, it undergoes an adiabatic process. The first law of thermodynamics may be written as the delta n equal to R divided by Cp ln P equal to 0, which means the heat the heat is exchanged between the systems is 0, which is simply known as the blah 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 things. D ln n equal to 0. Okay, now if it is defined as a temperature as a parallel would be equal to delta 0 is does not affect the system by which using the adiabatic constants. Okay, and the next one is thermodynamic process and the first law. Now you already know about the briefly know about the isothermal process and adiabatic process and what are the processes are used in the thermodynamic system. Okay, in order for an isothermal process to take place, where assume the system is in constant with the heat reservoir. In general, we assume that the system remains in equilibrium throughout the all process. Okay, now an adiabatic process is one where there is a no heat flow into or in or out of the system. Now you look at the graph. Um, now the zero is the constant one. X-axis value is V, which means volume, and the y-axis value is P, which means pressure. Now we consider the isothermal process and adiabatic process, and also points like A, B, C. Okay. Now the A is the starting point. Now A is the starting point and B is the ending point for an isothermal process. According to parallelly, A is the starting point of the isothermic process, sorry, adiabatic process, and C is the ending point of the adiabatic process. Okay. Now, uh, if you know about the isothermal process, you have to know about the isobaric and isovolumetric processes. Okay. Now I'm going to tell about the isobaric and the isovolumetric process. An isobaric occurs at the constant pressure. Okay, constant temperature means isothermal. Constant pressure means isobaric. Constant volume means isovolumetric. Okay, now same we all know about the look at the graph. Zero is the starting point. Zero is the constant one. X-axis value is the V for same both graphs, and y-axis value is the P for same both graphs. Okay, A to B, A to B, and that line considered as the process. Okay, A process is this isobaric process is the straight line, and isovolumetric process is the vertical line. Okay, this is the difference between the isobaric and isovolume temperature. And now the what is meant by the if the pressure is constant, the work done is the pressure multiplied by the change in volume, which means W. W means work equal to P dot del V. P is the pressure, V is the change in volume. Now is an isometric process. Isometric process means the volume does not change. You already know about that. The volume does not change. The work done is zero. So now we note about the work done W equal to zero. P dot del V equal to zero. So the system does not accept the any heat transfers or any values in this system. Okay. For process when the pressure varies The work done is the area under the PV curve, which means nothing but pressure and volume curve. Okay, now look at the graph. There is several points is denoted by easily understanding the P process volume curve. Okay, now look at the graph. Starting point is the zero, and the x-axis is as usual V. P axis value is, sorry, y-axis value is P. Okay, now there is some points VA, which means volumetric process starting point. VB, which means volumetric process ending point. That means that's what the VA is pressure. So isobaric point starting point, and BB is the ending point of the isometric volume. If you consider that there is an opportunity to do a same process, a simple process by using, we can study the three process with one process. Okay, we can simply understand the three process by using a one process. Okay, A to B is isothermal process. Now consider the D point. Okay, A to D, which means the isobaric. Already know about the isobaric is a straight line, and isovolumetric is a direct vertical line. Okay, horizontal line, vertical line, and the A to B isothermal is a curve. Now, in this process, simply thermodynamic process and the first law. Okay, we already know about the isothermal process, isobaric process, isovolumetric process, and adiabatic process. What is constant in this process? Which means in the isothermal process, T is the constant. In isobaric process, P is the constant. In isovolumetric process, V is the constant. And adiabatic process, Q is equal to 0 is the constant, which means the Q is the heat transfer. Okay, how the process like isothermal, isobaric, isovolumetric, adiabatic processes affect the first law. Okay, the basic is the first law of thermodynamics. The first law del U equal to Q minus W predicts del T equal to del T equal to 0 makes del U equal to 0. If you have any notes, you can copy it also. So Q makes, so work done equal to how the heat supplied is equal to how the work done is simply in happened in the isothermal process. Now the next one is isobaric process. In this process, P is the constant, which means pressure is the constant. So the first law equation becomes the Q equal to del U plus W equal to del U plus P dot del V. Okay. Now the isovolumetric process, in the isovolumetric process, V is the constant one, which means delta V equal to 0 makes W equal to 0. So Q equal to delta V, which means how the internal energy affected is nothing about the how the work done, or else on the how the or else it became a how the energy transferred is the simple one. Now the next one is adiabatic process. In adiabatic process, Q equal to 0. We already know about the in adiabatic process the Q1 is the simply we already know about the Q is the 0, and now the first law of thermodynamics equation becomes the del U equal to minus V, sorry, minus W, which means W is the work. Now we can say it's theoretically in adiabatic process Q equal to 0 delta U minus delta V. Now the next one is how the human metabolism and the first law is affected. If we apply the first law of thermodynamics to a human body, it becomes like we already know about the first law of thermodynamics equation delta U equal to Q minus W. Okay, we know the body can do work. If the internal energy is not dropped, that must be energy coming in. It is not in the form of heat. The body loses the heat rather than the observing it. Repeatedly, There must be energy coming in it is not in the form of heat. The body loses the heat rather than the observing it, rather than it is the chemical potential energy stored in the foods. Okay, now we all know about the how many calories and burn. We actually discussed about the metabolic rate with the help of how many calories per hour burned, like that, kilocalories, like that. So metabolic is the rate at internal energy is transferred into the body. Okay, when we are making the activities like this, only sleeping and sitting upright, slightly activity, eating, dressing, householding works, work at moderate or tennis, walking, running, bicycling is okay. Now, metabolic rate at the sleeping is 60 and in what 70. Sitting upright, metabolic rate is sitting upright in kilocalories per hour is 100 and watts is 115. Light activity like eating, dressing, householding works at the time metabolic rate is in kilocalories is 20 and in watts is 230. Moderate work like tennis, walking in the times the metabolic rate is 400 and the 460 in watts. By running is 1000 and 1150, and at the bicycling 110 one sorry 100 and 127 is the metabolic rate of this activity during the internal energy transferred into the body. Okay. So the second law of thermodynamics introduction. You guys already know about the initial state, the lateral cup assembles and then the lateral cell cup landing, and this one. This one is the reverse process. Okay, initial state, lateral and lateral state. Now, now you can assume that the absence of the process illustrated above they indicate the conservation. Okay, conservation of the energy is not about the whole story. If it's where movies run back onwards, we would perfectly normal to us. But not like this happened in this real life. So the absence of the process illustrated above the indicated indicates the conservation of energy is not the whole story. Repeatedly, if it's where movies ran backwards, look like perfectly normal to us. Second law of thermodynamics introduction. The which means the previous one continuity. The second law of thermodynamics is a statement about the which process occurs, which do not, which do not. Okay. Now there are many ways to state the second law of thermodynamics. Here the one heat can flow spontaneously from a hot object to a cold object. Okay, heat can flow from a hot object to cold object. It will not flow spontaneously from cold object to hot object. Okay, simply heat can flow spontaneously hot object to cold object, but it will not flow spontaneously from cold object to hot object. Simply hot to cold happen. Cold to hot not happen. That's it. Simply you can guys remember it. The second law of thermodynamics simply establishes the concept of the entropy as a physical property of the thermodynamic system. Okay. Entropy predicts the direction of a spontaneous process and it determines whether they are irreversible and impossible despite obeying the requirements of conservation of energy. It means you guys know about the conservation of energy. In physics and chemistry, the law of conservation of energy states that the total energy of an isothermal system remains constant. This is the law of conservation of energy based on the physics and chemistry. Okay. Now, come to the second law of thermodynamics. The second law may be formulated by observing that the entropy of an isolated system left to the spontaneous evolution cannot be decreased as they always write at the state of thermodynamic equilibrium where the entropy is the highest. If all processes in the state are reversible, the entropy is constant, and increasing in the entropy accounts for the reversibility of natural process, often refers to in the concept of arrow time. Historically, the second law was an empirically finding that was accepted as an thermodynamic theory. Okay, actually, we now know about the statical mechanism. Okay, now I'm going to tell about the statical mechanism. The statical mechanism provides a microscopic explanation in the law of the probability distribution of the states in the large assemblies of an atom or molecule. So repeatedly, statistical mechanism provides a microscopic explanation of the law in the terms of probability distribution of the state of an largely assembly of an atom and a molecule. The second law has been expressed in many ways. Its first formulation were predicted to proper definition of an entropy were based on the caloric theory in Carnot theorem. Credits to the French scientist Sadi Carnot. Sadi Carnot, that's why it's called as the Carnot theorem, whose is invented in the 80s 24. Think about it, 80s 24 is very previously. So the efficiency of and conservation of heat to the work in the heat engines has an upper limit. Okay. Now you can also know about the second law based on the concept of entropy came as the German scientist Celsius. You guys already know about this name Celsius, Kelvins, like the terms. In this scientist who invented the based on the concept of entropy became the German formula statement that heat can never passes from an colder to a warmer body without some changes connected there with occurring at the same time. The second law of thermodynamics can also used to define the concept of thermodynamic temperature, but this is usually declared to the zeroth law of interaction. Okay. Now we already know about the first law of thermodynamics. The first law of thermodynamics provides the definition of an internal energy and a thermodynamic system and express the law of the conservation of energy. The second law, as usual, the second law concerned with the direction of a natural flow. It asserts that natural flow remains only in the sense and it is not reversible. Okay, for example, when a path for a conduction and radiation available, heat is made available heat always flows spontaneously from a hotter body to a colder body. Such phenomena are accounted for in terms of entropy. If an isolated system is held initially in the term of thermodynamic equilibrium by internal energy, partially immersible wall, and then some operations make the wall more permeably, then the system spontaneously evolves to reach a final new internal thermodynamic system, and it is totally entropy S is increasing. If a frictional now what is meant by a frictional reversible energy? It does not happen. What will we become? Okay, let's see. In a frictional reversible system, a infinitesimal increment of an entropy of a system is defined as the result for an transfer of heat to a closed system or exit of energy but not transfer to a divided by the common temperature of the system in equilibrium. The surroundings which is applied to the heat. It means that delta S is equal to delta Q divided by delta T. Different notations are used to the amount of heat and the amount of entropy because the entropy function of state while heat like work is not. For an actually possible process without exchanging the mass with the surroundings, the second law requires the increment of a system. Entropy fulfills the inequality. Closed system actually represents as the delta S directly proportional to the delta Q divided by delta T. This is the basic general process for this case may occur including the work being done on the system. Okay. Which have an frictional and various effects. Which have the frictional and various effects in the system because a chemical reaction engineering may be in the progress of because of the heat transfer actually occurs in the irreversible driven by the finite difference between the system temperature and the temperature of the surroundings. Note that the equality still applies for a pure heat flow, which is the basis of the accurate determination of the absolute entropy for a pure substance from measured heat capacity curve and entropy changes at the phase transition. Okay, that is calorimeter. Now come to this slide. The second law of thermodynamics is the state about the which process occurs, which does not do. Okay, there are many ways to state the second law of thermodynamics. Here is one: heat flow. Heat can flow spontaneously from the hot object to cold object. It will not flow spontaneously cold object to hot object. Okay. Now, what is meant by the heat engine? It is an easy procedure to understand the thermal energy using work, but how does not one procedure work? Usually thermal energy, sorry. Repeatedly, it is an easy to produce, sorry. It is easy to produce thermal energy using work, but how one produce using thermal energy like what? Okay. This is a heat engine. Mechanical engine can be obtained obtained from the thermal energy only when heat can flow from a higher temperature to lower temperature. Okay, this is a heat engine. Mechanical energy can be obtained from a thermal energy only when heat can flow from higher temperature to lower temperature. Now we will discuss only the engines that run repeatedly cycles that the change in internal energy over a cycle is zero as the system returns to a initial system. Okay, now the heat temperature. Now that the high temperature reservoir transfers an amount of heat to the engine where parts of it is transferred into the work and the rest QL is exhausted to the lower temperature reservoir. Note that all three quantities are positives. Okay, repeat the slide. We will discuss only engines that run in the repeating cycle. Okay, now the change in internal energy over a cycle is zero as the system returns to the initial state. The higher temperature reservoir high temperature reservoir transfer the amount of heat to the engines where part of the it is transferred into a work and the rest. Okay, that is QL is exhausted to the lower temperature reservoir. QL means lower temperature reservoir. So note that all three quantities are positive case. What is happened in negative case is seen in the heat reservoir system, which is probably next to the work. Okay, now this is the heat engine. Yeah, system engine is the one type of heat engine. Okay, this is system engine reciprocating type. Okay, this is the first one. Now we already know in these terms for high temperature the boiler is used, for low temperature the water is used. Okay, the water is pumped to the steam for using the boiler because of this one. Now the heat input of the water is converted into the steam by using the pistons. It takes the work. Okay, and the piston means it take the work so that the steam boilers is transferred into the low low temperature to high temperature by using the condenser, pump, piston, and the system boiler like that one. Now the second one is heat engine. We already know these types of diagrams. You have seen about this is the piston piston model. This piston model is actually where using in the cars, vehicles, motors, and some other agriculture equipments. This the internal combustion engine is the type of heat engine as well. We also know about the intake. What is the intake value and exhaust value is in hydrogen anchored. Both ways are closed. Both ways are opened. One way is closed. One ways are open. Okay. Both valves are closed. Both values are opened. Cylinder, piston, and then one is both valves are closed by using the rings. Okay. Now the exhaust valve open to the exhaust pipe. The exhaust pipe is also have the same procedure. This one is the I think the last one, E type, exhaust type is using in these bikes. Now the next one is heat engines. Heat engines means bad as a heat engine need a temperature difference, otherwise the work done on the system in one part of the cycle will be equal to the work done by the system in another part, and the network will be zero. Why does a heat engine need a temperature difference? Otherwise, the work done on the system is in the one part of the cycle will be equal to the work done by the system in another part. The network will become a zero. What is meant by network? Network is nothing but what work is done by a currently using system is a network. Okay, there's no need about the no need about the worry about the network, which means the work how produced by the current system is known as the network. That network will be become the zero. Otherwise, the work done on the system is also will become a equal to the system of the cycle. Okay, now the next one is heat engine. Efficiency of the heat engine is the efficiency of the heat engine is known as E equal to W divided by QH. Okay, the efficiency of the heat engine is the ratio of work done, means W, and heat input Q. Okay, W is work, heat engine HEA, heat transfer. This is the simplest. Okay, now using the conservation of energy to eliminate the W, we find we already know about the work is also known as the heat transferred and QH heat transferred minus QL by QH. Okay, now we can also derive the equation like derive the equation E equal to first one is W divided by QH. The W is transferred as the QH minus QL divided by QH. Furtherly, the equation becomes more simplification equal to 1 minus QL divided by QH. We can cross multiply the items for getting the previous equation. Okay. Now the fifth last part is heat engines. The Carnot engines were created to examine the efficiency of the heat engines. It is highly idealized. Sorry, repeatedly. The heat engines were created to examine the efficiency for an heat engine. Okay, the Carnot engine was created by examine the efficiency of the heat engine. Okay, it is highly idealized as it have no friction. Each leg of the cycle is irreversible. So the Carnot cycle consists of the isothermal expansion, adiabatic expansion, thermoisothermal compression, adiabatic compression. And then examples on the next slide. Okay, the first one is heat engine, which is the isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. You guys know already know about the constant volume zero, and the x-axis value is the volume, y-axis value is the volume, how the work transferred, and how the energy transferred, how the work happened. According to this, the four becomes here. We consider the A, we consider the two slopes, two curves in this temperature lower to temperature lower, temperature higher to temperature higher. Okay, now we have to generally assume the points A, B, C, D. Okay, 4 points in the Q, work down and work high. Q means work. So heat energy transfer to high and heat energy transfer to low. Okay. Now in the isothermal expansion, the A point and B point are readily joined in the curve, and last one is the D and E. D and E in the adiabatic compression. D and E curves are joined. The next one is point C and D in the isothermal compression are readily joined. And the last one is adiabatic expansion B to C. are really joined. Okay, these all the ones in the compression works the readily all one the compression works Q become the zero. Okay, for an ideal reversible engines, the efficiency can be written in the terms of temperature. E ideal, E ideal equal to temperature high minus temperature low divided by temperature high. Okay, more simplification by the previous equation, it becomes 1 minus delta, sorry, temperature low minus temperature high. This is the Carnot efficiency. This is, this is the Carnot efficiency by using the ideal equations. Okay. Um, Real engines have some frictional loss. From this, we see that 100% efficiency can be achieved only if the cold reservoirs is that absolute zero, which is possibly. Now, the real engines have some frictional losses, and the best achievement is 60 to 80 percentage of the corner value is the efficiency. Now, the refrigerators, air conditions, and the heat pumps, the applications. The applications can be thought of as heat engines operating in reverse by doing the work. Heat is extracted from the cold reservoir and exhausted in the hot reservoir. You can simply, by understanding by watching the previous diagram on the slide. Okay, this one also the derivative only about this diagram or anything like that. Previously, our fridge, like told that we have fridge, but let's talk about refrigerators in this process. In this refrigerator system, we can understand where the low pressure is assumed, where the high pressure is assumed, where the high pressure vapor is consumed, where the compressor and the motor is worked, where the plug is. This is the fridge setup inside the. And actually now I'm going to understand the fridge concept by teaching you guys. Okay, cooling coil from inside the refrigerator to coil like a expansion coil and high pressure condensation coil known as Q coils. Okay, EB compression motors are working by transferring the high pressure. So the high pressure will to the expansion coil. So the after the expansion coil, the high pressure is reduced to the low pressure by using the cooling coils inside the refrigerator, and the Q from the refrigerator's coils become the very low. Now the next concept is refrigerator performance is by measured by the coefficient of performance. That means CO, coefficient of performance, COP equal to QL minus work. Refrigerator and air conditioners. Okay, now the substituting substituting the COP value as QL divided by W equal to, it was already knew about the QH minus QL is W, also we can replace the W by using the QH minus QL equal to 0. So now then this one is for refrigerator and air conditioner in practical conditions. Okay, now then COP ideal conditions. Ideal conditions become the TL divided by TH minus TL. This becomes okay. TL more for more simplifications TL 1 minus TH. By using these equations, we can easily understand the coefficient of performance, which is uh, coefficient of performance. Okay, now the next one is refrigerator and air conditioner. The heat pump, the heat pump can heat house of winter. Okay, simply known as the already coefficient of performance is COP. COP is equal to UH divided by W. So cold out, cold outside minus warm inside. This is the house. This is why also actually like cold out. And the heat pumps are used to evaporate the heat outside. The cold does not come inside. So the heat pump is the product. Yes. Okay. Now the next one is entropy and now the next one is entropy and the second law of thermodynamics. Definition of a change in entropy is where the amount of heat is added to the delta S equal to Q divided by T. Q divided by T. You guys already know about the delta is the entropy of the system and equal to Q is the work and divided by T is the temperature. Another statement of the second law of thermodynamics, the total entropy of an isolated system never decreases. Entropy is a measurement of disorder of system. They use the yet another statement of the second law. Natural performance tends to move towards the state greater than disorder. Example, if you put the sunlight and sugar in your coffee and stir it, you will mix it with that is uniformly milk and sweet mixture. But the amount of stirring will make the milk and sugar to become coming out from the solutions. Repeating examples, if you put milk and sugar in your coffee and stir it, you will wind up with coffee that uniformly mix that uniformly mixes milk and sweet. No amount of stirring will get milk and sugar to combine amount of solution. Okay. Another example is by tornado hits the building, there is a major damage. You will see a tornado approaches a pile rebel and leaving the building behind you its path. Thermal equilibrium is a similar process that uniform finally state had more disorder than a separate temperature in the initial stage. Growth of an individual and evolution of a species are both processes on increasing disorder. Though they violate the second law of thermodynamics, there are no isolated systems and energy come into them from a food and sunlight, air and energy also use them. Okay. Now the second law of thermodynamics is one that defines along time and process will occur, they are not reversibly and move and that run backward will look silly. Another consequences of the second law in natural process some energy becomes unavailable to do this laws. If we look at reverse as a whole, it seems inevitable that the more energy is converted to the unavailable forms, and the ability to do the work anywhere will gradually vanish. Okay, this is called the heat death of the universe. Repeating, if we look the universe as a whole, it seems inevitable that the more and more energy is converted to a unavailable form, the ability to do the work anywhere that will gradually vanish. This is called the heat death of the universe. Okay, the next one is statistical interpretation of an entropy and the second law. The macro statement of a system is specified by giving its macroscopic properties, the temperature, pressure, and so on. A microstatic pressure describes the distance and the velocity of an every particle from every macrostatic site. There are no or more microstatics. Now, statistical interpretation of entropy under the second law. A simple example, toss in a four coins. The macrostatic describes how many heads and tails are there. The microstatic list is a different way of achieving the macrostatic state. Microstatic state. Microstatics. Microstates. Okay. Now look at the diagrams. Macrostatic has the four tails, three heads, one tail, two heads, two arms, one head, three tails, four tails. Okay. This is the number of macrostatics. This is the number of macrostatics. This is the number of microstatics. This is the simple concept. Now that we assume that each macrostatics is equally probably that probability of a macrostatics that depends on how many macrostatics are in it. The number of macrostatics quickly becomes very large if we have hundreds coins instead of four. It's table on the next slide that lists some macrostatics, how many macrostatics they have. They probably relative that each macrostatics will occur. Not that the probability of getting fewer than the low 28 or 28 are extremely high. Now, probability of the various macrostatics for a 100 kilometers of macrostatics. This is the number of macrostatics. Probability this becomes 100 hits. Okay, we getting 100 hits, 0 hits. We getting 100, 99 hits, or 1 times, or 90 hits, 10 times like this. This is the probability. Now, we can say that second law does not forbidden the second process. All macrostatics are equally like. However, some of them may have an extraordinary low probability of occurring. A lake freezing on a hot summer day before February and reassembling itself, all the air into moving into single corner, remembering how low some probability gets some men getting from 4 kinds to 100. If we are dealing with many modes of materials, they can become so rare as to be effectively possible. Now, the generation of the electricity often involving a form of heat engine, whether it is powered by biomass or solar or cooling towers or future of the many power plants. Now that repeatedly look at into the slides, the generation of electricity often involving in the form of heat engines. First one, that again of cooling towers, the next one, the third one, many power plants. Okay. Now the last one is thermal pollution, global warming, and the energy resources. Source of an energy is water, wind, stream. These are the electrical source of this energy. Electrical generator, electric energy turbine, okay, which means using the sources we can run the turbine and then we can get the energy. And the heat output of any heat engine QVL refers to the thermal pollution as it must be observed by the environment. Air pollution emitted by power plants, industries, and consumers. In addition, most form of the combustion results in the buildup of CO2 in the atmosphere, contributing to the global warming. This can be minimized through the careful choices of fuel and process. The thermal pollution, however, is a consequence of the second law is unavoidable. It can be reduced only by reducing the amount of energy we use. This is the simple way to reduce the amount of energy. Now, what is the problem solving in the thermodynamics method? The first one is carefully note it down. First one is define what is the part of the system and what is the part of the surrounding. Repeatedly, what is the system and surrounding part. Okay. And the next one is be careful before getting before getting into the second one. Yes, just think about the be careful of the sense of work and heat when using the first law of thermodynamics. And the next one is be careful about the units. Be sure that you are using the sum to the problems. Express the temperature in Kelvin. The next one is efficiency is always less than the one. Entropy increases when the heat is added and decreases when the heat is removed. Summary of this chapter is first law of thermodynamics. First law of thermodynamics and the isothermal process temperature is constant and heat process flow is exchanged. What then by gas at constant temperature, W equal to work equal to P dot del V is the pressure and the change in flow. Okay, now the heat engines can change into the useful or means to temperature difference and the efficiency of the heat engine. Now we want to know about the first law of thermodynamics. W equal to Q minus W. The next one is E equal to W divided by QH and E equal to W divided by QH equal to QH E equal to, we can further using the more simplifications, we can get the 1 minus QL divided by QH. The upper limit of the efficiency is only about the upper limit of the efficiency of the ideal TH minus TL divided by TH equal to 1 minus thermal L divided by refrigerator and air conditioners to do what extract heat from the cooler resin and send it to the warmer resin. Very simple. We already know discussed about the C coefficient of the performance. Coefficient, coefficient of the simply QL QL divided by W. Heat pump. As usual, it's given by the heat pump. Which means heat pump means the coefficient of the performance is simply the QH divided by W, which is the if it is refrigerator means it's basically QL divided by W. Okay, how the work is transferred into the system and how the energy transferred into the system. So the second law of thermodynamics. Heat flows spontaneously from a hot object to cold object, but not the reverse. The amount of given heat cannot be changed into new entirely work. Natural flow tends to the increase in entropy. Change in entropy delta S equal to Q divided by T. Q divided by T entropy is a measure of disorder. As time goes on, less and less energy is available to do useful work. Now the we all goes to the last one time we call it. Okay, now discuss about the first law of thermodynamic and what are the thermodynamic processes and the first law and what is the human metabolism according to the first law of thermodynamics and the next one what is the second law of thermodynamics, how it is affected the heat engines and refrigerators and the entropy according to the second law of thermodynamics. The last one is order to disorder, unavailability of energy, heat death, practical interpretation of entropy and the second law, thermal pollution, global warming, and energy. Now the change in internal energy of a closed system will be equal to the energy added to the system minus the work done by the system on its own. The law of conservation of energy written in the form of cases is the isothermal process. An isothermal process is one where the temperature does not change. This one is the movable piston and the last one is the ideal. And in order to already know about the isothermal system, isobaric system, isovolumetric system, and adiabatic system. According to this, how the system remains through the movement. Well, now the adiabatic process of one the same graph procedure, and the next one is the isobaric process. This is the vertical line and the horizontal line. How the differentiate the isobaric process and the isovolumetric process. The process, if the pressure is constant, then the pressure is multiple into the changing volume. This is the first law of thermodynamics. Simply all about the W equal to W work P is multiplied by the change in the delta of P. Okay. Now the next one is isometric process, the volume does not change, so the work done is zero. For process where the pressure varies, the work done under the energy field become, which is the over the process, and the differentiated one is the constant. How the first law changes according to the flow changes. Now the apply the first law thermodynamics to the human body, it becomes the unknown W equal to E dot del V becomes the del U equal to Q minus W. Okay, now that we all know about the body can do work. If the internal energy is not to do, there must be energy coming in. This is not about the form of heat. The body less heat rather than the absorbing heat. It is the chemical potential energy stored in the food. Now the metabolic rate. Metabolic rate at the internal energy is transferred into the body, shaping, shaping light activity and moderated work by cycling. Metabolic disturbance. The absence of the process irritated indicates the conservation of energy. You know, it's normally it's quite possible, impossible to be backward forward. The second law of thermodynamics statement which process occurs there are many ways to state the second law of thermodynamics. Here, one heat flow can spontaneously hot object to the cold object. The spontaneously cold object to heat object. Now it is easy to produce thermal energy using work wherever the one does not work using this is the heat energy. Mechanical energy can be obtained through the thermal means only when heat can flow from a higher temperature to lower temperature. We will discuss only heat engines that the turning repeatedly the changes in thermal energy over the cycles or the system returns in the initial state. The higher temperature is only transfer into the amount of heat. The also the conclusion of this term is like after thermodynamics, isothermal process, and evening process are done by the gas. Heat energy of the upper limit of efficiency. What is the coefficient of performance by using refrigerators? What is the coefficient of performance by using heat pump? Cycle of thermodynamics, change in entropy. Entropy is a measurement of disorder and growth is the less energy available to use for work. So the session is on. Thank you for your patience.